It will take more work to stop the smaller truck. Since work is equal to average force times the stopping distance, the work energy principle implies that it will take more force to stop the smaller truck in a given distance. Since it was such a short amount of time, none of the trucks were able to stop, resulting in a car crash. Each car has kinetic energy directly before the collision. At the end of the collision, both cars are at rest and the total kinetic energy of the system is zero. The faster the work done during the crash, the greater the power that'll be felt from impact of both cars. There was a lot of power coming from the bigger truck, so both cars collided and skid. With the third car that was involved with the crash, the velocity is known because of the relativity between the first two cars. There was not enough static friction acting from the ground to the wheels on the car, making the car come to a complete stop and resisting it from sliding, so it would result in a crash. There is a force between the bottom surface and the top of the surface. They are pushing against each other, resulting in the tire to move.
Искать в телефоне любимую и не слышать гудки одинокие.
This high-speed car collision is an inelastic collision. The calculated momentum of the cars before the collision and added together is equal to the momentum after a collision when the two cars are stuck together. If the kinetic energy was calculated before and after a collision, some of it had been converted to other forms of energy. In this collision, we notice that the momentum is conserved, even if it is a collision. When the velocity of the car changed, the momentum also changed along with it, making it crash into the other car. This was a change in impulse.
Обходится компании примерно в $28. Еще один дорогостоящий компонент – модем, обеспечивающий работу.
Both of these cars had constant acceleration when the collision occurred, so their velocities are equal to the sum of the final velocities if it were to be divided by 2. A greater acceleration for the same mass results in a greater force, which would mean that the passengers of the car would be subject to more violent movement. The net change in position is the displacement that was found from the different vehicles. The total length traveled by both vehicles is the distance. In this simulation of a collision, we have a Lamborghini Aventador of 1,380 kilograms going at 70 meters per hour, which is 31 meters per second. We also have a Honda Pilot 2014 of 2,765 kilograms going at 55 meters per hour, which is 25 meters per second. The Lamborghini is going southbound while the Pilot is going northbound. We need to find out the velocity of both cars after the collision and the direction they go after they collide. We have the equation MAVA plus MBVB equals MA1VA1 plus MB1VB1. With our given masses and velocities, we plug them into the equation. MA equals 1,380 kilograms, VA equals 31 meters per second, MB equals 2,765 kilograms, and VB equals negative 25 meters per second because of the direction that the Pilot is going. We then have 1,380 times 31 plus 2,765 times 25 equals 1,380 VA1 plus 2,765 VB1. This is then equal to negative negative 26,345 equals 4,145 VAB1. You then divide both sides by 4,145. The ending velocity of the collision is negative 6.4 meters per second. The collision is going the way the pilot was headed. This is because it was a direction with the greatest force, and this is